welcome everyone who has joined to the Exascale Computing Project's Workforce Development Webinar Series. I'm Dr. Suzanne Peretti-Kuhn from ECP and from Oak Ridge National Laboratory, where I'm a high-performance computing engineer. This webinar series is brought to you by the Exascale Computing Project's High Performance Computing Workforce Development and Retention Action Group. The mission of this action group is to develop a equitable, diverse, inclusive community and culture for computing in the Department of Energy National Laboratories. And our workforce webinar series is aimed at that mission. This will be the fourth webinar in our series. And right now I'm putting a link in the chat. We record all our webinars, so you can see those links here. So I'll put that link live in the chat and you can check out our other webinars. Today we have Dr. Damian Rouson from Berkeley, Lawrence Berkeley National Laboratory, and he's going to talk to us about Black Lives Count towards accountability efforts to diversify computing. Before I get him started though, I'm going to give him a proper introduction. So Damian is the group leader for the Computer Languages and Systems Software, or CLASS group, at Lawrence Berkeley National Laboratory. The CLASS group studies, designs, and develops new parallel programming languages and execution environments, including compilers, libraries, and networking middleware. Damian's research at Berkeley Lab explores the use of machine learning to accelerate predictions of climate change's regional impacts using Fortran 2018 and UPC++. He's also founded the Sorcery Institute, a California public benefit nonprofit corporation for research and education in computational science and engineering. The Sorcery Institute offers training courses, publishes open source course modules, and funds a PhD fellowship at Cranefield University. Damian has also co-authored a textbook, Scientific Software Design, the Object-Oriented Way. And he's also taught courses on Fortran 2018 and Agile software development. He is an alternate member of the Fortran Standards Committee, and he holds a Bachelor's of Science from Howard University, a Master's of Science, and a Doctor of Philosophy from Stanford University, all in mechanical engineering. Thank you so much for giving us this talk today, Damian.
Thanks for the invitation, Suzanne. I'm really glad to give this. And this talk actually started, I think there's at least one member of the audience who was there when I had 4 slides on diversity at the end of my job talk. And so I actually then ended up expanding on that a little bit in a keynote that I gave at the International Fortran Conference last fall. And then this year, it seems to have become pretty popular on the circuit because I've been asked to turn it into a full talk several times. So some of you, if you saw the Black History Month talk that I gave at Berkeley Lab in February, or a talk that I gave to the U.S. Research Software Engineer Organization, a keynote in August, then you've probably seen a lot of this material. I do have a couple of new things that I'll talk about today. So hopefully, even for those who've seen it before, there's a little bit new. So I try to organize this somewhat like a technical talk: background, motivation, data and analysis, solutions and conclusions. And that's intentional, partly because I would like to see us start to be more rigorous when we talk about diversity and more analytical in the same way that we are about the science. And so these are, I don't have a funded project that, produced this work, so I haven't maybe gone as deep into the analysis as I would like, but these are sort of the baby steps that I'd like to offer to people to think about if we want to try and get more quantitative and more rigorous about thinking about diversity and inclusion. So a little more background on, I guess, what brought me to even include these slides in my job talk at Berkeley Lab, which was January of last year. And thinking about this stuff started a while before I came to the lab, but it very much directly relates to the lab. My first encounter with Berkeley Lab was when I gave a talk at the lab in 2005. I was invited by Tony Drummond, an African-American scientist who's now retired from the lab. And then I took an interest in Berkeley Lab a few years later and actually interviewed for positions at Berkeley Lab in 2012 and 2013. And I didn't get either of those positions. And I remember at some point along the way, as I stayed in contact with Tony, I asked him, "Do you know any other African-American scientists at the lab?" And he said, only postdocs and students, nobody in what the lab would call a career position. And during that time, I guess sometime around roughly 2016, I think Tony retired from the lab, and he was actually, we're about the same age. I'm 55. That was about, 6 years ago. And so it was kind of young to retire. And I thought it was a bit odd. And I thought through the fact that he had been at the lab for most of his career. And if he didn't know anyone after all that time, there might not be anyone. And I actually, at the time, happened to know the chief operating officer at Berkeley Lab. And I asked him this question. I said, do you think you have any Black staff scientists at the lab? And he wasn't sure and checked in the lab's database. The HR director reported to him. And so he was able to get the HR director to search the database and found out that there were none. Now, I should say that staff scientist is a very specific title here. It's the title that would normally have you in a PI role on projects and writing proposals and publishing a lot. There are also a lot of people making great contributions to the lab outside of that role. For example, as a computer systems engineer, one of my group members is in this talk today. And in my group, the staff scientists are actually very much in the minorities. I don't know the statistics overall for the lab, but we only have 2 staff scientists out of a group of about 14. So it's not that it's necessarily the most common role at the lab in terms of research, but it is a role, and it is an important role. And I would certainly imagine that there would be enough staff scientists at the lab that there would at least be one who identifies as African-American. So it raises the question, where is everybody? And I'll come back to that a bit later in the talk. My job talk then for this job was in January 2021, and I decided to focus on my work in Fortran. Gave a talk on why Fortran persists, experiences with teaching an underdog language, new tricks. A little motivation for what I'd like to talk about in this talk. Back in April, the Biden-Harris administration announced a whole of government effort aimed at generating disaggregated statistical estimates to characterize experiences of historically underserved groups using survey data. Also increasing access to that data and conducting robust equity assessments. But I really want to focus on the generating disaggregated statistical estimates and take a look at what that looks like here. So let's dive into some data and maybe a little bit of analysis. And for those of you who might have joined after I said it, I'm perfectly happy to take questions during the talk. I expect that if I work pretty fastly, I'll go through these slides in about 45 minutes, which will leave time for questions as well. But it's fine to interject. I'm not very good at watching the chat when I give a talk. So maybe Suzanne, if you see a question for me in the chat, you can let me know.
I've got you covered.
Okay. So this is the demographic data for Berkeley Lab that we have online. And one of the things that I notice about it is that we have underrepresented minorities grouped together. So that's Blacks, Hispanics, Native Americans. And we have other people of color as a group. That's Asian/Asian American and Pacific Islanders. And then we have people with 2 or more races and ethnicities and a grouping for white employees. So the first thing I would say is that if the goal is to characterize the experiences of underserved groups, then there are underserved groups here, historically underserved groups, that you can't tease out in this data because we've been aggregated into multiple groupings. So for example, if there are 7.79% technical staff who are from underrepresented minorities, that wouldn't necessarily tell you that there were any Black scientists, for example, in that grouping. And so I believe that we need to disaggregate further. I was recently discussing this with Valerie Taylor, who's a director of the Mathematics and Computer Science division at Argonne National Laboratory. This was just last week. She also pointed out something really interesting that I had never thought about, even though I've been looking at this for a while, which is that the one race that we have chosen to fully disaggregate is also the only race that is not historically an underserved group. So I think that really only strengthens and bolsters my call to disaggregate this data further. And I am engaging with our leadership and with the IDEA office, which is our Inclusion, Diversity, Equity, and Accountability office, to push for further disaggregation of the data. Part of why I want to see it disaggregated is because we need accountability. I was really excited when I first came to Berkeley Lab about this acronym that I've never seen anywhere else, and I believe it was invented here: Inclusion, Diversity, Equity, Accountability. At the same time that I'm excited about adding that word accountability, once we add it, we have to live up to it. One of the root words for accountability is count. And so I guess I would pose the question, can we really say that Black lives count if we can't count Black lives, right? So I think that's an important piece of data that we need. Good news is, along the way, I've discovered that there is one web page you can go to that points you to the demographic data for all 16, or excuse me, I think there are 17 DOE national laboratories, and I'm not sure which one is missing here, but we have 16 links directly to the demographic data for 16 different laboratories. And in particular, just to give you an example, Argonne National Lab does disaggregate in the way that I'm requesting here, so that you can see specifically African-American/Black called out as a distinct group. I don't have it in this talk, but as Valerie pointed out to me last week, what's really cool is that if you go to this page, you can also get intersectional information. I'll talk about what is meant by that, and what the real implications of that are a bit later. But you can see, for example, what percentage of people in a certain group are both African-American and women. And I think the more fine-grained we can get with the data, the richer the picture we get of diversity at an organization. I was actually pleasantly surprised to find that there are 6 of the national labs that disaggregate in the way that I'm describing. So I hope that sets a precedent, and I hope that we can see the other 10 do the same thing. So in terms of analysis, what can we do to think about the distribution that we actually see in a given place? And I'm just going to give you a couple of, fairly simplistic ways to think about the analysis. Some parts of it I'm not going to carry all the way through. We'll leave that to the reader, to the viewer. But let's think about the percentage, let's think about the pipeline, the percentage of African Americans who would likely take positions at a research laboratory. So specifically, I'm going to focus on those with doctoral degrees. Not everybody who's in a research position at the lab has a doctoral degree, but I'm just using this as a population, partly because I found some good data. If you look across various fields, it's got 3.2% of doctorates awarded in 2019 were African-American in mathematics, 3.4% in computer science. Some fields are a bit higher, like 4.2% across all of engineering. There were some fairly specialized fields that actually were even at 0. So not too surprising that there's spread. But let's just take, even as a floor, we could imagine that if we average across all the fields, we're going to have at least 3% African Americans. So I guess in terms of analyzing this situation, my thought goes to, what's the probability that we could actually end up at 0? Fortunately, we're not at 0 now. When I gave a similar talk during Black History Month for the lab in February, a couple of people reached out to me after the talk and introduced me to 2 other Black staff scientists at the lab. So I can verify that there are 3 of us. I haven't yet gotten an exact number out of the IDEA office because they're hesitant to make this kind of data public. Part of the reason they're hesitant is because when the numbers get so small, you can sometimes figure out how a specific person identifies, that you can see that level of detail in the data. At the same time, one of my concerns is, if you're telling me that the reason you can't publicize the data is because the number is too small, then what you're telling me is that if the problem's bad enough, we can't tell you about it. And I find that problematic. So one of the themes of my career, of my professional life, at least one phase of it, if you look back at some papers that I was publishing in the range of around 2004 to 2008, I've oftentimes tried to bring a more analytical viewpoint to things that we normally talk about qualitatively. So during that period, it was about scientific software design. And I was making scaling arguments about software complexity and looking, for example, at object-oriented programming and how trying to come up with a metric or a way to estimate the number of lines of code you might search to find a bug. And, showing that with the different aspects of object-oriented programming have different impacts on that process. When you think about inheritance versus encapsulation, scales quadratically in one case and linearly in another. So let's try to think a little bit more analytically about this as well. We oftentimes think, okay, well, the numbers are so low, that explains why we don't have as many. Okay, but quantitatively, you do a job search, and let's say there's a 97% chance, if there's only 3% African Americans, in STEM fields. And by the way, in computing sciences, we do hire from across the STEM fields. As Suzanne mentioned, my degrees are all in mechanical engineering. So I get that. I understand that very highly likely that for a given position you advertise, you're not going to hire an African American for that position. Makes perfect sense. However, if we imagine a random sampling, by the time we get to the second hire that we make in that process, if we assume that there's no correlation here and these are statistically independent samples that we're making, we have to multiply those probabilities together. So now we're down at 97% of 97%. Okay. And so you can probably kind of imagine where this is going, but if you haven't actually done the multiplication or the exponentiation, you might not realize just how stark a situation is when you get to zero. By the time you've hired 100 people, the odds of having zero by random chance, even in a population that's only 3% African American, are less than 5%. By the time you get to 200, the odds are about 0.2%. By the time you get to 300, 0.01%. So the way I would phrase this is, at least by random sampling, the odds that you get to zero in, I think 300 is probably not too bad of an estimate for the number of staff scientists we have on site here. It's probably a bit higher than that. The odds against that, I would say, are astronomical, to put it in qualitative, metaphorical terms. So since they're astronomical, and I'm, as I've talked about this kind of analysis with friends and colleagues, one of the things that's pointed out to me was, well, I'm not sure that's the right way to analyze that because we don't hire randomly. Okay, I get that. So we should probably get a little bit more sophisticated in our analysis. And since the odds against what we're seeing here are astronomical, why not take some inspiration from astronomy? Some of you might be familiar with the Fermi paradox. Enrico Fermi, Nobel laureate in physics, I think sometime back in the 1950s, was talking to a couple of other physicists. And, the question was, if the conditions for life are not so unlikely across, various planetary species throughout the galaxy, and if life is likely to happen on places where the conditions are habitable, where is everybody? Why aren't we picking up any signals, right? So I took that as inspiration and, for my job talk, put together this slide starting from the Drake equation. Many of you might have heard of Frank Drake, because of this equation. He was a physicist who just passed away fairly recently, I think about, if I remember correctly, about a month ago. I was fortunate enough to see him give a talk one summer when I was working at NASA Ames back around 2003, 2004. And back in 1960, he came up with this way to quantify the number of civilizations we might be able to detect in our galaxy based on these various factors. When I first saw this equation, it was a bit confusing to me that there was a rate term in it, the R star term at the bottom. Eventually, in thinking through it, I concluded that he was probably imagining a pipeline. You can think of like a pipeline on a processor, since we're all in computing, and think about filling the pipeline. And once you get to the point in this problem where the pipeline is full and you've reached some steady state in the process, then you can imagine that the number would scale on the rate of star formation times the length of time for which a civilization releases a detectable signal, right? For us, we've been releasing detectable signals since we've been producing radio waves, so maybe somewhere around 100 or so years. Hopefully, for the sake of all of us and posterity, we have at least a few more 100 years before we might hit the eject button or do something that would cause the civilization to go extinct. But it is conceivable that at some point, we stop releasing the signals, maybe either because the civilization isn't there anymore, or because we're just doing things differently, like we don't use radio anymore, now that we get a lot of our information online. So I like to group these terms together. On the right in parentheses, I have, the terms that relate to the pipeline. And on the left, with all these fractional terms, we have what I would call the filters, basically. So it's the fraction of stars with planets, the fraction of those planets that develop life, the fraction of those planets that develop intelligent life, the fraction of civilizations that release detectable signals, and then I neglected to mention the average number of planets that can support life per star. So you can imagine how that might be a reasonable way to estimate the number of civilizations we could find. And as I understand it, I'm not an astronomer myself or astrophysicist, but as I understand it, this equation has driven a lot of science since it was formulated. It gives you things to go after if you'd like to figure out the answer to this number. So I would say that if we're trying to have more diverse organizations, then we're in a search for African-American terrestrial intelligence. And again, I would group some terms here into what I'll call the pipeline. And the one term that I dropped was the NE term, the number of planets around a star that are habitable, because I didn't have a good analogy for that one. But I think we can take the rest of these terms and convert them into something that's relevant to this process. So let's say we're going to try and figure out the number of African-American scientists we should have in a given setting. So for the pipeline, we've got the average rate of African-American PhD graduation and the average career length, and then the fraction of those graduates in STEM fields. Then we apply filters, right? This is not actually a random process. So there's the fraction of African-American STEM graduates who apply for your positions, the fraction of applicants who match specific technical / project / programmatic needs, and the fraction of applicants who meet some measure of merit. So what I like about having an equation is it gives us a way to frame the discussion. When I presented this in my job talk, I said, I'm not going to carry this far enough to actually give you an estimate for N, but I will suggest to you that my working hypothesis is that if you do carry through this analysis, you're going to have a very hard time justifying 0. But let's talk about some of these terms and some of the things that we can do to impact those terms. Actually, before I do that, I guess the last thing I'll say is, let's see. Actually, no, let's just jump into that. So we'll look at what we can do to impact this. So I would say the fact that I would say that the first analysis demonstrated that what we're looking at is not random. And one of the things I'd like to point out is that analysis where we multiply the probabilities, there's nothing about that that is specific to the problem we're talking about, which is hiring African-American PhDs, other than the specific number, the 3% that I chose as a floor. You could apply that same analysis to any room you walk into. For example, here in the state of California, back around 2000, 2001, we reached a point where no group was in the majority anymore. No racial or ethnic group was in the majority. And a bit later, I think around 2015, we reached a point where the white population was no longer the largest minority. The largest minority was Hispanic. So here in the state of California, if you walk into any setting, whether it be a grocery store, a workplace, a school, or what have you, if any group is in the majority, you're witnessing a situation that is very much outside of, away from equilibrium, away from what statistics would suggest the population in that setting should be. And I think that's a really important thing to think about, because if you can't get to that randomly, then ultimately that means you've gotten there deterministically. There are decisions that have been made that brought that setting to that composition. That could be the good news, because if it's deterministic, then hopefully we can solve it. So for example, the fraction of African-American STEM graduates who apply for your positions. One of the things I think we need to do is expand beyond our existing networks. A lot of hiring happens within our professional networks. We send job ads to faculty or other national lab researchers that we know. We oftentimes hire our own postdocs or students. I'm not necessarily arguing that that itself needs to change. I think it's probably impractical to think about that changing to a large degree, although it's not impossible. One of my friends made the point to me, you know, we don't really know how employees are going to work out. We should probably just set a bar and choose randomly above that bar. I actually think that's not such a bad idea, but I don't think it's ever going to happen. So I think what we need to do is, rather than trying to change the pattern, let's at least expand our networks and make sure that we are collaborating with people from underrepresented groups. And one of the ways to do that is to go where the underrepresented populations are overrepresented, go where there's clustering, work with people at historically Black colleges and universities, Hispanic serving institutions, and what have you.
That was my thinking.
The fraction of applicants who match specific technical / programmatic / project needs. What we did when I was at Sandia National Labs, I was there from 2007 to 2013, is we set up this program that we called the Early Career LDRD program. And I actually, at the time it was set up, I don't think I knew that it was targeting diversity, because I remember being, you know, a bit surprised when I found that out a bit later, after I had hired someone into my group, Carla Morris, who's a Hispanic woman, Black, you know, PhD researcher who just made distinguished member of technical staff at Sandia recently. And someone else in a different department had also hired an African-American PhD. I didn't actually know that they were targeting diversity, but it turns out that that's what it led to. The importance of that program was that it was a fellowship, essentially. It was 2 years of funding that a manager could use to hire someone to just go out and try to find the best talent, and not to have to think about specific project needs. Because it is true that oftentimes, if we're looking for a unicorn, if we need someone who has expertise in a very specific area, and you multiply the probability of finding that with the probability of finding an African-American in general, sure, you do end up with a very small number. I think there could also be issues where we may be aligning with fields that aren't as represented, where underrepresented groups are overrepresented. For example, I've been corresponding some with a computer science professor at Howard University, my alma mater, and when I asked him if they had any faculty working in HPC, he said no. And it was a bit of a shocker to me, but I guess HPC is an older field, and everybody's charging into, you know, things like AI and quantum computing and what have you. And so from that perspective, it kind of makes sense, but it also just kind of makes the point that when you have a small department, it's not a very big department that they have there, they can't cover everything. And it might just be that you end up with alignments that are misaligned with what the labs, for example, need. And for that reason, you know, that could possibly explain some of the numbers that we see. Unfortunately, that early career LDRD program was funded by stimulus funds back under the Obama administration. And so it went away when the stimulus money ran out. The closest thing I think we have to that are fellowships like the von Neumann Fellowship, or, you know, different fellowships we have at the labs where we hire top postdocs independent of their field. But those are very limited positions. I don't think they're going to really move the needle on the diversity question. So I think we need something broader. The fraction of applicants who meet some measure of merit. One of the things I'd like to point out is that there is research data that demonstrates that more diverse work groups produce better results. For example, there was a paper that came out a couple years back about the diversity innovation paradox. Unfortunately, the reason they were talking about a paradox is that even though they were able to discern innovation, they applied machine learning to the dissertations. It was a nearly complete collection of the PhD dissertations from 1977 to I think 2015. And they applied machine learning to try and detect innovation, where terms are being used for the first time, or where two terms are being brought together for the first time, things like that. And what they were able to find out is that people who add diversity into the field tend to do things that are more innovative. Unfortunately, they also found out, and this is why they call it a paradox, they weren't necessarily rewarded for that. Honestly, the work that I talked about earlier when I was trying to analyze scientific software development in an analytical way and talk about scaling arguments for things like bug searches, even though it's the stuff that I'm probably the most proud of in my career, it's the least cited papers of anything I've ever written. So this is not a plug for citations, but it's not always rewarded, when you're from a smaller group and you're innovating. Sometimes you're just out there. When I gave the Black History Month talk that I've alluded to, actually, let me step back. I'm sorry. I'm going to say one more thing about this. At the end of my job talk, when I said that I'm not going to carry this all the way through, to do a complete analysis, but you'll have a hard time justifying zero. Another thing that I brought up in terms of the measure of merit, one of the people that I first started to talk about this stuff with, who's a close friend, who is in astronomy and has worked as the vice chancellor for equity and inclusion at UC Berkeley, and is African-American and Jewish, commented, well, the problem is that we're really looking for 3 sigma people. There's one thing I really like about that statement, because at least it's quantitative, at least it's precise. There's also one thing that bothers me, is that if it is a precise statement, then it is incumbent on us to determine whether we actually are using that level of precision in what we're doing. I would posit that we're not, but my question is, if you say you're going for 3 sigma people, where's your data that, well, first of all, what random variable are you talking about? Second of all, where's your data that shows that everyone that you've hired in the last several years is 3 standard deviations from the mean in that random variable? And thirdly, where's your data that shows that that random variable is predictive of future success in your organization? Because basically, if you can't do all those things, I'm going to call BS. That was the end of the job talk, and somehow they still hired me. And they're still letting me go around and give this talk. Just before I gave the Black History Month talk, a friend, Hakeem Oluseyi, who's currently the president of the National Society of Black Physicists, pointed out to me that Keith Jackson, who used to be at Berkeley Lab, was talking about a lot of this stuff 20 years ago. He sent me this paper from 2002 that was in APS News, where he was talking about the status of the African-American physicist in the DOE national labs. And he was pointing out that there's a tendency when we talk about diversity to jump to talking about the pipeline, and then to jump from there to talking about K through 12. He was making the point that I am now really passionate about. I really try to shift the conversation away from K through 12. And I really try to get people to think about the pipeline quantitatively, not just qualitatively. Because at the end of the day, even if we expand the pipeline, if we're not hiring the people, it doesn't matter. And so, and also the K through 12 population puts a long timeline on when we can solve it. So when we talk about diversity, I'm not saying we shouldn't engage in K through 12 efforts. Absolutely we should, no question. I'm saying that's not a solution to the pipeline, at least not in the immediate term, because we have to at least be willing to hire the people that are in the pipeline before what we do in the K through 12 population will matter. And that's essentially what he was saying back then, is that, this isn't a pipeline problem. It's a problem, as he put it, in the spigot, that we won't open up the spigot to hire people. So what he was proposing to solve it then is to set up summer programs, summer schools, get people from underrepresented groups involved in this work. And he's talking specifically about undergraduates and graduate students, and I would also say faculty, because those are the people who are already in the STEM pipeline. Let's make sure they're engaged in the kind of work that's being done at national labs or whatever hiring setting we're talking about, so that they're in our networks and they're qualified. And those are the people that we're looking to when we're hiring from our professional networks, which we so often do. I've been very fortunate that to have Deb Agarwal as who's a division director here at Berkeley Lab, as an ally in this, because she's been helping me go after more data. And there's 2 slides I'll show here that I think I haven't shown in talks, publicly before. So this is, relatively new, hot off the presses. And looking at gender, I would say what we're looking at is a pipeline problem. We are actually, if you look at the people who apply for our positions, so in the CS area, and this is looking specifically at staff hiring, so it's not including students. The picture can be slightly different when you look at students. We are actually hiring, so we have in our process of hiring, there's various stages that an applicant can go through. The hiring manager will review the resume and select out those who meet certain qualifications. Those will typically transition to a phone screening. If the phone screening goes well, those will transition to an interview, and of course, the top candidate then is hired. So meets qualifications on the left is an actual designation in our database. This is an official decision on the part of the hiring manager that this person meets qualifications. And if you're not going to at least do a phone interview for someone who meets the basic qualifications of the job ad, you better have a reason. You'll have to actually write something down to explain to HR why you're not going to progress this person to the next step. So in terms of women, I'd say we're actually doing pretty well. We're actually hiring at a rate that's slightly higher than the representation of the population, which I'd say is a good thing. I mean, if it were 50-50, then I'd say the best thing would be to try and match what's in the pipeline. But given that we have one group that's underrepresented, I'd say it's great that we're actually hiring even more than there is in the pipeline. But we can only go so far in that regard. So this is the pipeline, I would say here, is the rate limiting step, right? What's fascinating and possibly disturbing, but I think we need a lot more analysis to really understand this picture, so I won't say for sure it is disturbing, is that when we look at race, we see a different picture. We see that those from the underrepresented minority groups apply and are designated as meets qualification at a 10% rate, but are hired at an 8% rate. And when you first think that, you think, well, it's only 2% difference, it's not a big deal, but actually that's a 20% hit. That's pretty significant, assuming we have enough numbers here for the statistics to be representative. Same thing happens with those in the other people of color. So remember, that's Asian/Asian American and Pacific Islanders. 33% meet qualifications, only 20% higher. That is a massive hit. And all of the uptake from those losses and those populations is going to the hiring of white employees. There could be many reasons to explain this, that could be innocuous. Maybe more people from these other groups, underrepresented minorities and people of color, are from sensitive countries, and we can't hire from, but there's only 6 countries on that list. So that's probably not the explanation. Probably a more likely explanation is we're hiring from within our networks aren't sufficiently diverse, right? Even though the applicants are, more diverse than you'd see in our ultimate hiring population. I think there's a lot more work to do here to understand this. So I'm not going to just come out and say, this is discriminatory hiring practice. It might not be. But what I would say is we need to know. And I think that we need to know in every setting. I think each of you, wherever you are, should hopefully be asking for similar data to this. Because if you don't, you can't control what you don't measure. We need measures like this to know whether we're doing the right thing. This is probably a little bit out of order. I tend not to think in a very linear way. So this probably should have gone right after the Keith Jackson's paper, because talking about solutions, that's because the two previous slides were new. So I wasn't quite sure where to put them. But Keith Jackson was saying, let's set up summer programs. Let's bring in students, graduate students and I'd say also faculty to work with us so that we expand our networks. The good news is that's what we're doing, at least at Berkeley Lab for 7 years, I guess 8 years. We had this program called the Sustainable Research Pathways Program. It actually won an HPC Workforce Diversity and Inclusion Award in 2021. It's led by Marianne Leung, who's the president of Sustainable Horizons Institute, which is a nonprofit. And it's a nonprofit that's focused on workforce development, primarily for the DOE national labs. And what it does is a workshop that I refer to as speed dating for research. In the workshop, lab staff present their work in lightning talks, one slide, 1 or 2 minutes. Faculty and students present their work and their interests. We go into smaller group meetings and then ultimately one-on-one meetings. And if a match is found, then there's a funded collaboration the next summer. As of last year, this made the leap so that now there are 8 labs involved. Last year, it was called Sustainable Research Pathways for HPC, SRP-HPC. And now this is continuing. It's happening again this year, and it's going back to just the original name, SRP. So this is fabulous. I think we need more things like this. I think we need it in other fields besides computing. That's one of the things I'd like to see happen here at Berkeley Lab, is programs like this get adopted across the lab. I hope that those of you who are, at a lab that has this program take advantage of it and also work to get it adopted across the lab. There's no reason that this needs to be specific to computing. But the other big thing we need is to actually hire from this pool. I've known Marianne Leung for quite some time. I was the chair of the broader engagement workshop at the SC conference back around 2013, roughly 2012. And Marianne was the deputy the year that I led it. And then she took over as the chair of the workshop the following year. So we've been working together and corresponding closely for a long time. And so I've known about this program and cared about it. And I've always wanted to see it as a pipeline to the lab. Wanted to see it become part of our hiring pool. That hasn't happened to the extent that I would like to see. As I understand it, there's been about 2 people, hired into staff positions at the lab over the 8 years of the program. And those 2 were both hired by Sylvia Crivelli, who's one of the people who started SRP. So we still haven't solved, the leaky pipeline problem, where we're getting people here, we're forming the relationships, but we're not getting them here in a more permanent way. So
Damian, we've had quite a lot of discussion in the chat, and I didn't know if you wanted to take a break and look at,
sure,
and let me relate some of those things to you. Directly related to this question, Merritt Earl has asked, how do you think we challenge the problems of implicit bias combined with reluctant staff who don't think they need to change? How do we break the bias of an insular culture that maintains its demographics because others just aren't a good fit?
I can tell you how I choose to challenge it. I can't necessarily give you great results to say that my approach is effective yet, but I choose to challenge it by speaking to scientists in the language of science, like in the language that they understand. I really think we need to put stark numbers in front of people like I'm talking about to demonstrate that we can't blame zero on the pipeline. There's enough in the pipeline that we should have hired some by now. I think the more we get quantitative and analytical about this, the harder it's going to be for people to come up with reasons why it can't happen. That's my solution. I don't know how persuasive it's been yet, but I've got one thumbs up in the audience. So thank you for that, Merritt.
And there's a lot of questions. There's several up the line that relate to the question of retention. Paige Kingsley and Kristen Cleese Van
Yes.
Dam are asking,
Yes.
I believe, how does this relate to retention? How do we build a culture that can actually hold on to our new hires that are from underrepresented groups? How do we make that?
So when we talk about diversity and inclusion, that's the inclusion piece, right? We can get the population here, but can we keep them here? And one of the things that will help to keep them here is to create a more inclusive environment. One of the main thrusts of Marianne's organization is normalizing inclusivity. Okay, so what we need to do is when we're having conferences, hold things like guided affinity groups where you bring specific groups together and in a way that addresses the experience of that underserved population in the conference, but also open those up so that anyone can attend. It's not exclusive. But because it's targeting the underserved populations, it does a couple of things. One is it inverts the ratio, something I picked up from a paper that Marianne wrote, inverts the ratio that the people in the underserved group experience when they go to the main conference, and I guess to the other parts of the conference, I'll say, and that changes their experience of it and makes it more likely that they'll have a good experience and they'll stay. The other is that since this is open and we're inviting everyone, and maybe I should ask Marianne to talk about this because I think she's here with us, what it's doing is it's normalizing inclusivity. It's saying this is a part of this conference and everyone at the conference is welcome to participate. Practices like that. The collaborations that are formed through SRP, and I do tend to talk about SRP a lot, the collaborations that are formed hopefully become long-term collaborations so that I'm now collaborating with a professor at Northern New Mexico College, a Hispanic professor and his student who's also Hispanic. Because of the SRP program last summer that I participated in, the important thing for me being before last summer, I had never heard of Northern New Mexico College. So we need to expand the networks, but we need to do it in a way that's sustainable, that the relationships continue and continue to work with these people. That I think is another way of normalizing inclusivity. Okay, so on my calendar, we're scheduled until 15 after the hour. Are we stopping at the hour or 15 after?
15 after is the stop point, and I hope everyone here can stay that long, but yes, so that's time for questions. There's just one more that I'm hoping you'll address, which is about the K through 12 pipelines. Those are pretty important, but I think your sentiment was that we need to do more than that, but not neglect that particular pipeline, correct?
Right. I would say the reason I'm not so passionate about the K through 12 work is that it's already happening. I support it. I think it's great. It needs to keep happening. My main point is it is already happening. There's another problem that we're not talking about that's not happening. So the K through 12 grows the pipeline. Hopefully our efforts grow the pipeline. What the problem I'm talking about is even once people are in the pipeline, we're not hiring them at a level that's representative of what is in the pipeline. So I'm trying to shine a light on a new problem, a different problem. And not a new problem because Keith Jackson was writing about the exact same thing in 2002. Go ahead, Suzanne.
No, right. If you need to continue, there's a lot of great discussion in the chat. So maybe we could have you continue through and then we can take those more questions as we
I'll show a few more slides. I'll try to wrap up by the end of the hour, and then we still have the 15 minutes after. Okay, so this is kind of, in a way, jumping back to more motivation. Like I said, I'm not a very linear thinker, so I thought about moving this up higher in the talk, but I think this is really the best place to put it because I like to put the numbers first, because I hope that that's what draws scientists in and convinces them that this is an important problem. But here's another way to look at it. A diverse workforce does work differently. I've actually seen in Supreme Court arguments, where one of the justices was deriding the notion that physics would be any different if it were more diverse racially and ethnically. This book puts the lie to that, okay? This is by Stephen Alexander, Brown University cosmology professor, and he wrote this book called The Jazz of Physics. And I love this book because when I first saw it, it was like, you know, it was, I'm a big fan of Zen Buddhism, and in Zen Buddhism, they use these koans, which are teaching mechanisms that are intended to shock you into some new realization. I would normally see a title like this. I've seen lots of books where I would expect it to be the physics of jazz. I'd expect to see something about vibrating strings and acoustics and what have you. But this flips it on its head. This is about the jazz of physics. It's about the fact that he's African-American, he plays jazz music, and his music inspires his physics. He goes to jam sessions and works through physics theories inspired by what he's hearing. Now, when you first hear that, it sounds kind of hokey probably, but when you read the book and realize that he has quotes from some of the top physicists saying kind of the same thing, Nobel laureates like Abdus Salam, who was speaking to Jim Gates, who's a Black physicist who was a student at the time that he said this. So one day when your people do physics, it will be like jazz. I think to many eyes, maybe to more modern eyes, that probably sounds a bit patronizing, but I'll say that we have to take things in context. And I'll say that in context, the listener definitely did not hear it as patronizing, heard it as a compliment. And I think the basic argument is, if music inspires physics, and if he's playing from a Black music tradition, then you have to say that his culture is changing the way he does physics. Even Albert Einstein, apparently, when someone asked him about his theory of relativity, he said, it occurred to me by intuition, and music was the driving force behind that intuition. My discovery was the result of musical perception. It's kind of hard to argue with Einstein. So I'd say a diverse workforce does work differently. I'd also say a diverse workforce does different work. This is from a paper that I published with Lois Kerper-McKinney and Marianne Leung at the Collegeville 2020 workshop. And we later then published it as a blog post on the Better Scientific Software website. And this was not a technical paper, it was an interview where Lois asked questions of Marianne and me, because Marianne and I are both from underrepresented groups. And one of the things that I said, and so the paper is just a transcript of that dialogue. I do most of my work in Fortran, as I mentioned, and it's an unusual choice. One of the things I was saying is that, why did I make this choice? It's hard to say for sure, but when I think back, this was written in 2020. When I think back to 20 years prior, when I was deciding which direction to go with my work, I think one of the reasons that I was able to adopt sort of an underdog language is because I was coming from an underdog community. In all honesty, if I'm completely frank with everyone here, I basically didn't think that those in the mainstream were going to respect my work a whole lot anyway. I don't expect to have the same level of credibility when I walk into a room being African-American. And so I didn't really see the reason to chase after the herd and go with what everybody else is doing. I was happy to do my own thing, and I was happy to embrace the underdog. So I think there is actually kind of a relationship between the fact that I chose Fortran as my adopted language, or my primary language. I've programmed in, a dozen or so different programming languages, but the fact that I chose program, I think, partly relates to my background. And so oftentimes I think people think about diversity and they sort of imagine that we'll get more people from underrepresented groups, we'll get more Black and Brown and Native American people here, but we'll kind of just be doing the same thing, or at least implicitly, I think that's what people are thinking. What I'm arguing is that no, when you get more people from these underrepresented groups, you will be doing different things. There weren't a lot of people in my division, probably hardly any, doing significant work in Fortran. So you hire the first Black guy, or the only at the time, and guess what? Now you're doing Fortran. There are correlations like that. You'll be doing different things. Programming languages are human languages. Some of the biases that apply to spoken languages also apply to programming languages. This is a short 2-pager that I submitted as a position paper to a workshop last December on scientific software, the science of scientific software. And, we were I collaborated with, this probably has the longest list of authors. Actually, there's a couple of names missing on this copy of it. We had 5 authors total, I think, for such a short paper. 2 of the authors were linguists. One is a professor of linguistics, Renee Blake at NYU. And they were bringing in, by analogy, another technical language, which is aviation English. And they were talking about the fact that non-native English speakers were being put at a disadvantage in the testing of whether they had learned this dialect that is used in aviation by control towers and pilots and what have you, because they were being asked to do things that didn't correlate with outcomes, and they weren't as good as at that particular part of the curriculum, even though it didn't matter as much. And so we need criteria that actually relate to what's being done, and we can end up with biases or discrimination, that even in technical languages, whether it's a programming language or in this case aviation English, by virtue of how we measure merit. I probably don't have to make the case that Fortran is an underdog language, but just to give you an idea of how bad the situation can be, it doesn't feel great when you can pull up papers. This is a paper from 1975 by Edsger Dijkstra, and I found it in a course syllabus from 2001, where he's referring to Fortran on the lower left as the infantile disorder, because Fortran was the first widely used programming language. By now 20 years old, is hopelessly inadequate or whatever for whatever computer application you have in mind today. It is now too clumsy, too risky, and too expensive to use. Imagine if someone described your life's work, if you've done your best work in Fortran, someone's described your life's work as part of an infantile disorder. You can write Fortran in any language. This is actually a phrase that a lot of software engineers use as a way to say you can write bad code in any language. Fortunately, I do see a tide turning. I've been really impressed with the amount of funding that DOE has invested in the LLVM Flying Fortran compiler, for example. My group was partly funded to do work on the Flying compiler. And there are papers like this one that's on the right that say real programmers write Java like Fortran. So I think people are kind of coming back around to recognizing some value in the language. And the language is still more popular than most people realize. This is from actual runtime data from our supercomputer center, NERSC, demonstrating that Fortran is very much on par with C and C++ in terms of when they look at the cycles that are occupied by runtime libraries from various languages on NERSC platforms at the time. The most recent data I have is from 2018. So one of the last points I want to make is about intersectionality. This is a term that you hear a lot in the social sciences. It was popularized by Professor Kimberly Crenshaw at the UCLA School of Law, has been hugely impactful in the social sciences. The last time I checked was a couple months back, and it had 27,000 citations in Google Scholar, still growing pretty fast. And what she was dealing with is certain types of discrimination that only occur at the intersection between two groups. She was writing about a lawsuit, a Black woman who was suing a corporation for discrimination or discriminatory hiring practices. The court threw the case out. This was a Black woman who was suing. The problem is Black woman is not a protected class. Black is a protected class, but the company was hiring a lot of Black people, except that they were mostly doing manual labor and they were mostly hiring men. Woman is a protected class, but they actually were hiring a lot of women. It's just that the women they were hiring were mostly white and they were in front office jobs, like receptionist. So if you're a Black woman, you're out of luck because you don't fit the stereotype that they have for the roles that they put people in. So I think to some extent, you're seeing intersectionality when you see a Black Fortran programmer. Maybe a better analogy, though, in terms of the way she's talking about it here, in terms of a certain type of discrimination that only happens at an intersection. It occurred to me more recently that what's really odd is that I'm a Fortran programmer in an applied math and computer science organization. It's at least throughout most of my career, it hasn't been that hard to find Fortran programmers in the settings that I've been. When I was at Sandia, for example, I had people in my department who were writing some of the most impactful codes running on platforms like Jaguar, which was at the time the top platform, and only certain codes could qualify to run there. And those were Fortran codes. But guess what? They weren't open source. And when they gave talks about their work, they only talked about the science. They only talked about the results, not the code. Partly, I guess, because of this stigma that we were talking about earlier. My adopted field is computer science. Obviously, the labs hire a lot of computer scientists. They just don't hire a lot of computer scientists that do Fortran. It's a really odd choice. And it's only when you're at that intersection that you might have a very hard time finding something. So I've got 2 last slides left. And again, getting back to solutions. I would say one of the things we have to do is think about diversity of thought in addition to diversity in all the protected classes in terms of what they bring to the organization. We need to resist juggernauts. When I look at data from NERSC, this is actually from about 2015, but I am almost certain it would be the same today. Over 90% of codes are using MPI. That's a juggernaut. And one of the problems in it becomes hard for other solutions, partition global address space languages, for example, PGAS, to get a foothold in the field, despite measurable benefits. The plot on the left is showing co-array Fortran, which is a PGAS language as of Fortran 2008, and even more so in 2018. And this is from a paper that I published at a workshop called the Parallel, actually this was the Parallel Applications Workshop. The newer instances of it are called the Parallel Applications Workshop, Alternatives to MPI plus X. So you can find another instance of that workshop at SC22 if you're going. It's all about people who are doing something other than going with the herd. And this is looking at simulation time, where we were able to show co-array Fortran having lower simulation times than a comparable MPI code written in the way that most MPI programmers would write it, most scientists at least, which is two-sided communication. We looked at 2 different versions of the co-array Fortran, one that uses MPI under the hood, but it's one-sided MPI, which most scientific programmers aren't writing, or it's OpenSHMEM, which is a whole other programming model. And in both cases, it outperformed the more traditional MPI code. What's really interesting is that it even outperforms the MPI code when MPI is under the hood, because there's better MPI there than you would write yourself. On the right, we see GasNet EX that's developed in my group that supports a broad ecosystem of languages, libraries, various programming models and applications, from NWChem EX for drug discovery to Exabiome for metagenomics. Really broad applicability. You can see that the network bandwidth saturates at a much smaller message size than you get with MPI in most cases. Hopefully I explained that right. Dan's here to correct me if I get anything wrong. So real benefits from switching, and yet over 90% of codes are still using MPI. So we need to think about other, diversity of thought. How do we do things that sort of, go against the norm? And that, I think, will also support better results and diversity in a technical sense. So to conclude, Black lives count. So let's count Black lives. Let's disaggregate our data so that we can see that group distinctly. The odds of randomly achieving a significant skew from what the distribution is in the pipeline, the odds against that are astronomical, especially the further you get from the distribution in the pipeline. It doesn't happen by chance. If it doesn't happen by chance, if it doesn't happen randomly, it's deterministic. Once we admit that, every problem is an opportunity. The great thing about it being deterministic is that it's solvable. There are things we can do, and let's push on organizations to do them. A diverse workforce does work differently and does different work. Programming languages are human languages. The point I was making in that paper that I didn't go into in detail on the slide is that source code is written for humans. If the only goal, if the only target of source code was the computer, we'd all still be writing machine language or assembly language. We write it in something close to English so that other humans can read it, those other humans sometimes being our future selves. Once you recognize that, it's not hard to make the leap that there will be biases that creep into programming language choice, just as there are in any other human language or dialect. And those biases can be intersectional, as I talked about. Inclusivity requires diversity of thought. Let's combat stigma. Let Fortran programmers write their Fortran without talking badly about them. And let's resist juggernauts. That's all for my talk. Thank you.
Thank you, Damian. That was absolutely excellent. And that's being reflected in all of the comments that are coming in. I think we could take people that if they want to unmute their mic and ask questions, but I just want to point out some of the themes that I couldn't get to because there are so many important ones up here. I think Kristen brought up the fact that it's very important that labs track their interns to figure out if they're being hired and see how they're doing in the STEM fields. And then Adam Jacobs points out that it's very important that leadership get involved in supporting diversity efforts. That pales in comparison of all the insightful comments that are actually above it, but that was what I saw. So if people would like to hold down their space bar or simply click the unmute button, you can ask questions directly at this time if you'd like to.
Hi, this is Kirsten Cleese from Brookhaven. I had a question. So we have, quite frankly, not enough Black American applicants to our positions. But at the same time, we had articles in the news saying that people on Long Island, where Brookhaven is, who are from the Black community, don't find enough well-paying jobs. And so we clearly don't do a good job at advertising for our positions, but I also wonder if we are doing something wrong that we don't look attractive to them or inviting.
Sometimes, well, let's see. Well, we have to figure out how to put the best face forward. You know, when I went to grad school at Stanford, I had a friend who was a year ahead of me, and I first met him when I went for a visit to the campus, and they actually had a weekend dedicated to Black admits, Black students who had been admitted, to try and recruit them to come to grad school there. And he told me, somewhat jokingly, he told me that his goal was to deceive us, to get enough of us there at once so that we would actually think that there were more of us around. And it worked. It really spiked the capture rate, the percentage of students who were admitted who actually chose to come. And I definitely have seen situations go the reverse. I remember when, back in the 90s, when Proposition 209 passed in California, which outlawed the consideration of race in public university admissions processes, and the Black population in Berkeley was decimated. Specifically in the law school, there was a point a couple years later when there were no Black students in the entering class. There was actually one who was admitted, but chose not to come because he didn't want to be the only one. So maybe we have to think about ways to put the best face forward when people are coming for a visit, make sure that they're seeing more people like themselves, you know, so gather the groups together that make the place feel welcoming. You know, these in conference settings, like the guided affinity groups, I think is what that's accomplishing, like Marianne Leung can talk about in more detail. But I think that's the best I can offer for a solution to that problem. It is very hard to step into a setting where you're the only or one of the few. So.
Thank you.
Are there any other questions? I see some coming into chat. If you please feel free to unmute yourself and ask those questions.
This is Sarah Del Valle from Los Alamos National Lab, and I wanted to get your thoughts about the systemic also, well, not this, well, there are systemic problems, but also how this system contributes to the lack of representation, and how we also need to tackle, you know, the system as a whole. And so I'm curious to hear what are your thoughts on, increasing leadership. And as we all know, the leadership across the national labs are not, don't have a lot of representation. And as you come down the leadership positions, you don't really see people like like ourselves. And so what are other things that we could do to increase representation so that we are more attractive to folks that are in historically marginalized communities?
Ooh, increasing the leadership. I mean, I think most of the leadership that I observe at the national labs grows from within. However, because the contracts do occasionally change, I'm guessing it's on the order of every 15 to 20 years, it might change to a new organization that's running a given lab. And the organization sort of gets decapitated and a whole new group comes in. There's not much that we can do about that. But at least up to that very top level, I think a lot of the leadership has grown from within. So we really have to grow the ranks, at the bottom of the organization, I think, to diversify the leadership. But again, I'll come back to numbers. One of the things I find interesting, when I've been given this argument that one of the reasons we don't publish the numbers is because if they're so small, you'll be able to pick out individual people. Well, one of the groupings, if you go to Berkeley Labs demographic data online, one of the groupings is senior leadership. And I remember at least at one time looking at that and seeing percentages like 75%. I think it might have been male versus female, like 75% for male and 25% for female. Well, when I see a round number like that, I can kind of guess that this is a multiple of 4 in the population, right? So my argument then is, if you don't mind exposing things at that level of detail in this small group, why not do it in other small groups as well, like the African-American population? I also think that we should at least publish the zeros. Maybe let's go division by division and at least publish the zeros, because if the number is 0, there's nobody's privacy to protect, right? So that's kind of the most I can offer you. I'm someone who has worked in a lot of different places, and I've never risen above the first layer of management anywhere I've been, partly because I don't hold my tongue, and you guys can tell that from this talk. So I may not be the best person to ask about leadership, and the high-level leadership at least.
Well,
you don't hold your tongue.
I think that, since you were talking about how, it takes, it grows within, but also maybe having term limits for all leadership positions. So you have enough opportunities for people to apply and to diversify your leadership team. I've been thinking about like 4 to 5 years, maybe, similar to Congress and the senators and everything. Obviously not on a yearly basis, but I think that could be something.
That is a spectacular point. It's funny that I am agreeing with you so much, because I typically am not a fan of term limits when it comes to politics, because I think the more experience someone has, the better they could be at what they're doing. However, in what we're talking about right here, I think what you're saying makes perfect sense, because whoever comes into that role is likely to be very experienced at let's say for the lab director position, it's highly unlikely that someone's going to come into that who's unexperienced in leadership at a national lab, right? So I think term limits in that setting makes perfect sense.
Damian, this is Mark, real quick on first, thanks for the great talk. I've seen it before, even better now.
Thanks.
Are you maybe willing, if you have a moment, to speak to the two sort of forces that pull on you, perhaps your actual research interests, which you enjoy doing and doing in computer science and in HPC and so forth, and then the other that pulls at you, I think, constantly, which is, constantly being asked to or speak to or address what's going on in the DE&I space. And I'm just curious if you can speak to that and yeah, just speak to that at all.
I'm not sure I follow what you're asking. I also got a little bit distracted because I had a nice compliment from Roscoe Giles, who I know well, in the chat. I don't usually watch the chat, so let me close that.
Well, just are you? I know from other Black researchers are often torn between being able to get the research done and being able to address very important problems in this space. Yeah. And I'm just curious if that's an impact for you as well, and if you could speak to that at all.
Wow, that's a very tough one. So I did take on a role as to lead our IDEA committee for our division. I have not done nearly as much with that position as I think could happen with it. We have monthly meetings. I've kind of largely turned it into a speaker series. We invite people to give great talks, and we've had some great discussions. I've tried to do a little bit more with it by soliciting a proposal from Sustainable Horizons Institute for more work they could do with us. What was interesting with that was that the proposal was turned down for the best reason. I wanted to see an analysis of our population and a comparison to national data at a deeper and broader level than I would have time to do myself. And the response from the lab leadership, this was 2 division directors and our associate lab director, was I wanted to have that study so I could first demonstrate there's a problem, because if I don't have the data, I can't even prove that there's a problem. And then we could start to talk about, more solutions. And the reason that proposal was rejected was because they said, we already know we have a problem. So it was actually the happiest I've ever been to see something rejected. There was no reason to spend a bunch of money on that. So yes, there can be a lot of attraction and pressure or nudging to do a lot of things that go beyond your technical work when you're one of the few. I have been willing to take on additional roles, but typically in fairly limited ways. And I was very clear with the lab about who I am before I came. I was asked to write a research statement, and the first sentence in my research statement was, I live to code, right? So I'm never happier than when I'm writing code, and I try not to get away from that for too long. So I don't have a great answer or a great solution, other than when you do take on these roles, do what you can to limit it, especially if you are passionate about the science. And if you're not as passionate about the science, then maybe it's time to think about moving into one of those roles full-time, and working in diversity.
Thank you, Damian. This has been an excellent discussion. We are past time. If you are willing to stay, I can leave the Zoom open. I just want to make a quick plug for the ECP HBC Workforce Development and Retention Action Group. Many of the topics that Damian talks about are things that we address in our monthly meetings. So if you're interested in joining us, contact me. I will make sure that you have the link there that I put at the beginning to that action groups page. And we take input from lots of people, and we want to know more about webinars like this and actions that we can take that are constructive and helpful to building a constructive, inclusive, diverse culture in the national laboratories for computing.
Great. Yeah, I just checked my calendar and I don't have anything else. We still have a lot of people here. So if there are more questions, I'm glad to take them. Otherwise, we can drop off. Feel free.
So there was a question went by. Are there any books you suggest?
Oh man, one other book. Okay, several. So I mentioned the Jazz of Physics. You'll see that in my slides. At some point I mentioned Hakeem Oluseyi. He's the current president of the National Society of Black Physicists. They've actually invited me to give a plenary talk in 2 weeks. So I'm gonna give this same talk once again or something similar in that setting. And his autobiography is so powerful. Run, don't walk to get that book. Take any adversity that any of us in this Zoom call have ever faced, sum them up, square it, and it still might be hard to compete with what this guy has dealt with, which I didn't even know, even though I knew him when he was going through a lot of it. We were grad students together at Stanford. He was in astrophysics, he was in physics. And wow. I mean, I don't want to give too much of it away, but it's way beyond what you can imagine. Really powerful. The name of the book is A Quantum Life. And his last name is Oluseyi. The S is pronounced like SH. Oluseyi. Oluseyi. Hakeem Oluseyi. So the third book I would recommend, and I was really tempted when I was thinking about this talk and preparing it, I was really tempted to take a slight detour and talk about this book, but there just wasn't enough time and I didn't want to go off on a tangent, which I so often do. Another book I'd highly recommend is called Whistling Vivaldi. So the classical composer Vivaldi, Whistling Vivaldi. It's by Claude Steele. He is a social psychologist. He's taught at Michigan, Stanford. He was the vice chancellor at UC Berkeley for a while. He's the person who invented the concept of stereotype threat, I think is the right term that social psychologists would call it. It's the idea that performance can very much be situational. You can take a group of students and give them a group of students who performed really well on the SAT, give them, these are undergraduates, give them a set of questions to answer, or a hard math questions to answer, but right before you give them that test, give them a survey. And the last question on the survey is their race. Then you have a control group where you don't have that last question there. They can show that it measurably suppresses the performance of the students who are from a group that is stereotyped as being less intelligent. It measurably suppresses their performance on the test. Even though these students were chosen because they had very high SAT scores, they're now being asked to do the hardest of the SAT questions in a setting where they were just primed by being asked about their race, which they know in society is stereotyped as being less intelligent. It's a really powerful book. One of the takeaways from the book that I kind of wanted to pull in here is that when you look at the data, sometimes you see really surprising things that you didn't expect. His work talks a lot about underperformance. Underperformance is defined as when you look at, let's say, an incoming college student, incoming freshman, and you look at their statistics coming in, their high school GPA, SAT scores, and you use that to try to predict graduation rates, graduating GPA, number of years to graduate, that sort of thing. It turns out that the Black students who come in with the same incoming indicators as white students perform at a lower level on the ultimate outcomes, the graduating GPAs, graduation rates, what have you. So turning things on its head, if you look at this case that's before the Supreme Court right now, it's largely about the fact that Asian Americans are being discriminated against because of affirmative action. The implicit idea being that affirmative action is benefiting the Black and brown people. Well, first of all, when you look at the Berkeley lab data, now that was not admissions data, it was hiring data, but still, I'd say when you look at the Berkeley lab data, yes, Asians are taking a serious hit. They are taking the biggest hit. But guess what? It's not going to benefit the Black and brown people. It's all going to benefit more white applicants being hired. So that's one way to turn things on its head. If you think about Claude Steele's data and his work and the fact that people are underperforming, what it's saying is, instead of having this conversation that we have so much about, well, we don't want to bring in, these underqualified students, they're going to have a hard time competing. No, we need to be talking about, when we get the most qualified students, what are we doing to them after they get here? They're underperforming where they should be with the same indicators as white students. So it's not about the students as much as it is about the environment. Whew. Don't get me going.
That relates to Deborah Penshoff's question. I hope she's still here. It's way up the chat, but she's talking about the connection between improving retention at the universities. Have we engaged the labs to work with universities to improve retention of underrepresented minorities?
That's a really good question. I would like to think that programs like SRP, which is, we're engaging us with a broad variety of universities, is helping with retention at those schools. I don't know the data. If Marianne is with us, she might have some data on that. But that's a question to ask and a question to answer quantitatively. Let's try to get that data. Let's talk about diversity as quantitatively and analytically as we do about the science.
There is an effort by the American Institute of Physics. It's called the Team Up Task Force. And they studied R1 research institutions primarily, but they studied the causes, particularly for astronomy and physics, because it's the American Institute of Physics, of what factors allow African-American students to be retained through graduation to a bachelor's degree. And they have a report that talks about the 5 factors that allow retention, and they do actively engage with the universities, with the professors they worked with. They actually studied for 2 years with social scientists at about 10 universities. It would be interesting to see the labs take up that sort of opportunity and that kind of study for these efforts, or the
Right.
universities for that matter.
That's great. Thinking back again to Claude Steele's work, one of the things he talks about in terms of what makes a difference for PhD students in particular, in terms of the retention, is connectedness, like feeling part of the group. And, you know, anecdotally, I can say that in my story, that made a humongous difference. When I first got to Stanford in grad school, I fell flat on my face. My first quarter grades were horrific. And I had a great PhD advisor who just retired recently, and I went to his retirement party and talked about this and the things that he did that made a difference for me. And including one of the first things he did was bring me into his research group. I had outside fellowship funding, so I didn't have to do research. I was not an RA, but he brought me into his research group anyway. And he did it specifically for the reason to connect me with other students. By being in the research group, that gave me an office. My office mates became my study mates, all of whom are still close friends to this day. So connectedness matters a lot, I think, and apparently there's data that shows that for PhD students at least. And I would assume something similar holds for other levels like undergraduates.
Okay, we're coming up on the half hour. Are there any final remarks or burning questions that somebody wants to ask? I will make sure that the book list is available with the recording. This will come out on the webpage. But do we have any last thoughts in the last 2 minutes here before the half hour?
So I've got a question, and I hope there's enough time to answer it. So you talked a bit about how we decide if people are qualified, and for me, it has a lot to do with kind of grouping together what we value and then measuring people by what we value. But I think in my experience, I've found that different communities value different things. And so success looks very different. Even though we may be capable of doing the same things, we kind of get around to a solution in very different ways. So I guess I have kind of two questions. So do you think we have a good understanding of what different communities value so that we can identify how they're working together to get to their definitions of success, and then maybe determine what they're capable of? And I guess that's the main question. And then what do you think is lacking in what the overall system, kind of value system, is in the laboratories and kind of these technical communities? What's lacking in that value system that's not capturing what is valued kind of in the underrepresented communities, and what we can use to identify what people really are capable of?
Yeah, so those are great questions. I think there certainly is clustering that happens that I think would tell us what different, I guess, subpopulations value. Like, for example, among the STEM fields, when you look at the health sciences, you'll find a higher representation of women, I believe, than in some other STEM fields. I'd also like to point out that this can change a lot over time. Women were much better represented in computing 30 and 40 years ago than they are today. And I don't know all the reasons why that changed. I don't know that anybody's ever put forward a great explanation that they can demonstrate, causally to be true. But so thinking about the health sciences, for example, as we hire more women, we might be doing more health sciences. So what we do will change, right? And thinking about the fact that it changes over time, we should recognize that this stuff is, elastic, stretchable. Like, it's not a fixed constant of nature, what population is in or is attracted to a certain field. Hopefully everyone has seen Hidden Figures. If you haven't, go out and see that. It's so powerful. And by the way, there's a frame in there where there's a picture of the cover of a Fortran book. And they were Black women programmers working for NASA, doing some of the greatest work to get the space program going, the calculations for spacecraft orbits and what have you. Black women Fortran programmers. There's an even more specialized intersection than I have. Yes, I think we can at least use data like that to figure out what groups value. I jokingly like to say I think a greater proportion of women like to work in fields that matter. I mean, in the health sciences, the impact is obvious, right, in the health of the population. Whereas there are some fields, that are maybe more abstract and theoretical. I'm absolutely certain that women have every capability that the male population has in those fields. They might be, on average, less attracted because maybe it's harder to see that field matters, right? So I think there's at least some ways we can figure out. People vote with their feet, like they vote by choosing where to go to school or what to study. And so we can maybe to some extent, for some reason, so my training was in fluid dynamics, computational fluid dynamics. And for some reason that's inexplicable to me, almost all of the Black researchers I've met in computation in fluid dynamics were doing computation and not experiments. And I've never quite figured out why that is, but it's just another example of where you get clustering and you can see that people value something. I have one friend recently who's a vice chancellor for diversity and inclusion at Urbana-Champaign who gave me a good speculation on why that happens recently. I can't think of exactly what it is now. Okay, well, I guess we have dwindled and can probably sign off, Suzanne.
I think so. Thank you so much for this talk, Damian. This was completely excellent.